Alright, number 74. Dana uses a rope to pull a box that weighs 300 newtons across a level surface with constant velocity. The rope makes an angle of 30 degrees above the horizontal, and the tension in the rope is 100 newtons. What is the coefficient of friction? We're going to draw a free body diagram. And so we know that, of course, it has a weight. Because it's in contact with the ground, there will be a normal force that's perpendicular to the ground. Okay. We also know that the box is being pulled at an angle of 30 degrees above the horizontal using a rope, so that's a tension force. And there is friction, so we can't assume it's frictionless because it is asking for the coefficient of friction. And so the intended motion of the box is towards the right side. So basically the friction is going to resist that and pull to the left. Okay. So now we can go ahead and sum up all of our forces. So in the x direction, we of course have the friction force, which is in the negative direction. And we see that the tension force is both in the x and y directions. So there's going to be some components of both x and y for the tension. So the x component points to the right, and the y component points upwards. Okay, then we'll see that the tension, the component of the tension that's in the x direction is the cosine, so plus cosine of 30 degrees. Okay, so now we have to deal with what's on the other side, so equals max. So we'll see here that the box is pulled with a constant velocity. So remember that the equation for acceleration is the change in velocity over time. Right? So if we have a constant velocity, we know that the change in velocity is 0. It's not changing. So 0 over anything, 0, this is a t, 0 over any time, doesn't matter, is still 0. So our acceleration in the x direction is 0. Negative f plus t cosine of 30 degrees is 0. You know that the friction force is equal to mu, so the coefficient of friction times the normal force. So minus mu times the normal force plus t cosine of 30 degrees. So again, we're solving for the coefficient of friction. So what we want is this, the mu right here. We know the tension, but we don't know the normal force. So again, we're going to look to the y components to see what the normal force is. So in the y direction, we have the normal force is upwards. We have that the weight is downwards, so minus w. And we'll see that we also have the y component of the tension force, which is the opposite of the angle. So we have a plus t times the sine of 30 degrees. Okay, and it's pulled across a level surface, so it's not accelerating off the ground. So we have no acceleration in the y direction. It's not going to jump off the ground. So that's 0. M times 0 is 0. So normal force will be the weight minus tension sine of 30 degrees. So the weight is 300, so normal is 300 minus t, which is 100, sine of 30 degrees. That means that the normal force is 300 minus 100 times 1/2, so minus 50. Which is 250 newtons. So now we can go ahead and plug that into the other side, our x side, and solve for the coefficient of friction. So minus mu times 250 plus 100 times the cosine of 30 is 0. So mu would just be then 100 cosine 30 divided by 250. What this comes out to then is 0.35. Remember that the coefficient of friction doesn't have units because the equation is F equals mu n. This is a force. Its units is newtons. And so is the normal force. So the mu couldn't be any other unit because then we wouldn't have newtons equaling. So our final answer is 0.35.